Hello and welcome everyone. In the last session we discussed about lists, which is a data type available in Python. It's a collection we discussed. Today we are going to discuss another collection which is called dictionaries. So let's begin. What is a collection? We also saw this in our previous session that collection is group of one more than one things. Collection is nice because we can put more than one value in it. So when you want a group of things to operate on, we create a collection. So this collection becomes one package, and we can collect not only a single type of item in a Python collection, that is list. As we saw, list was a collection of um, similar kind of items, or it can be also collection of different sort of items. For example, we saw that we can have a list that's a collection of mixed items like this. Here you have this collection as mixed types, that is numbers, strings. You can also have lists, tuples, and dictionaries inside the list. Alright, so dictionary is also a collection, but we have something different out here than a list. We'll see what are the differences between a list and a dictionary. So collection is again a group of things put together. Okay, and we have a bunch of values in a single variable. So as you can see here, we have assigned this bunch of values with this variable. So this variable is now referencing this collection, and going forward using this variable you can access the items in this collection. Okay, um, okay, we also have different ways of finding the different places in the variable. For example, if we want to move further in a list and see what are the items available to us, we can do so using indexing. If you know the index of a particular item, you can figure out what it is, and so on. Like if you know the index, you can get the item. If you know the item, you can get the index, vice versa. All right, let's move further and see the same thing. It is a duplicate slide, which it's meant for a recap of the previous one. Then what is not a collection? So numbers are not a number. If you take an independent number, it is not a collection, right? Variable, it cannot be just called a collection because it actually refers to a single object or single item, though that item itself is a collection. That's true. The variable cannot be called as a collection, or in fact the number cannot be called as a collection because it cannot be broken down into different items, right? 2 is 2, 4 is 4, and x is x. X is not a collection, 2 is not a collection, 4 is not a collection. Alright, so variables are not a collection, numbers are not a collection. What are collections? Strings are collection, lists are collection, tuple tuples are collection, dictionaries are collections, sets are collections. All right, so we have to deal with all these sorts of collections. All right, okay, so here is a very simple differentiation between a list and a dictionary. List is a linear collection of values that stay in order. So if you know a very good diagram in fact here, so Pringles, so these are a collection of linear collection. So the Pringles are in order, right? They are not, they are placed stacked up like this, right? These are your Pringles. They are stacked in a very linear fashion, very ordered fashion, all right? But dictionary is also a collection, but it is unordered. It's a collection, but it is unordered. List is a collection, but it is ordered. All right. So when I say unordered, they are not ordered, but it's a group. So it is called a collection. It's a group, but it is unordered. All right. But how is the item identified then in the case of dictionary? They are identified using their label. We'll see further how using a label they are identified. So here it is, a real world example. So in this right side diagram, you can see you have a bag with some group of items, and you can see we have given them label. In fact, what are the labels? Calculator is the item, perfume is the item, candy is the item, money is the item. So all these items are given a name, a label, so that they can be identified in the group. In the group, in the sense, in the given dictionary. So dictionary items in the dictionaries are identified using a label, using a name, right? Without using a label or a name or identity, you cannot identify an item in the collection. Which collection? In the dictionary collection. All right. Okay. So dictionaries are Python's most powerful data collection. And why so? Because dictionaries store the data using a label or an identity, as we discussed in the previous slide. So if we want to access any particular item, we just need to give the label or the name and we get the item. It's super fast access. So your access to any item in the collection or in the dictionary is very fast, because you don't have to search all over in the collection like in your list, right? In your list you need to figure out the index, go there and then take the element, right? So you need to know the index over here, right? Which is not a good way to remember things rather than remembering a name. Like you have a dictionary, an Oxford dictionary for example. So you've got words and you have got their meanings. All right. So you can figure out the meaning of a given word using the word. You don't have to say, hey, my word is at 745 page number 745. It doesn't sound good. It's tedious. So it's always good if you can refer your items in the collection using a name or a label or an identity instead of giving the page number or an index number or something like that. All right, and hence the search in the dictionary is very fast, right? So what does it say? Dictionaries allow us to do fast database like operations. All right, so you can do similar sort of operations using the dictionary. Okay, so dictionaries are not like a unique thing in Python. It is the similar namings or similar data structures are available in different languages. Like it is called associative arrays in Perl or PHP, properties or map or hash map in Java, or property bag in C# and .NET. Alright, so they've got different names, but a similar implementation is available in other languages too, right? Okay, so let's move on and see how we can create a dictionary in Python and how we can do certain operations. Okay, so the important thing to remember is that dictionaries are very good for performing search and storing things in a way that they are accessed very easily. Like you can see it out here that lists index their entries based on the position in the list, right? So as I said, lists are ordered and hence everybody has got their own position, whereas dictionaries are unordered and we do not have a given position so that we can access, go there, go to that position and get the item. It is not the case in the dictionary, right? Okay, so what in all, the thing is we need to access using a tag. As you can see over here, lookup tag or a name or a label or and whatever you call it, right? But you give an identity to access the item in the dictionary. All right. Okay, here we have a little piece of code which explains a little bit more. So you can see dict, like we created an empty list using the list function. Similarly, we are creating an empty dictionary using the dict function. And how are the dictionaries defined then, or declared rather? So we had declared the list as inside these square brackets. All right, and dictionaries are defined, declared inside these curly brackets. Okay, okay, so this first operation could be done in two ways. One is this, another is this. So either you can do this particular thing, that is d is equals to curly bracket open and then closed. This shows that the dictionary is empty. Both of these ways are to create an empty dictionary. Alright, now what is this next operation? This is very similar to the adding operation in the list. For example, how did you add an element to the list? Or in fact, how did you update it? So you said L of 2 is equals to 25, and the index number 2 then gets the value 25. But in this case, since we do not access the dictionary using an index, rather we access it using a name. So we give dictionary of, that is purse. So purse is an empty dictionary out here, and then we are saying purse, we need to add or update. Remember now, if there is already a key or a label with money already available, it goes and updates rather than creating one if it already is present. Okay, before moving further to this, let us see typical syntax of a dictionary. So how a dictionary looks like. So here is how an empty dictionary looks like, and let's see a very simple example of a complete dictionary. So a dictionary can also be called as collection of key value pairs. All right, when I say key value pairs, it is very similar to words and the word and its meaning. All right, and how are they separated? They're separated in this way. All right, as you can see, I have created a dictionary here. So as we said, the dictionary is represented inside the curly bracket. So here is my open curly bracket, and then we said it's a collection of key value pairs. This becomes a single pair, that is hello and wish. So hello becomes the key or the word, then the word and the meaning are separated by a colon, and this one pair is separated by the second pair using a comma. Alright, and so on. You can keep on adding items to this dictionary. So one item in the dictionary becomes one key value pair. So what is the key over here? This hello becomes the key, wish becomes the value. Similarly, the class becomes the key. So this becomes the in fact key 1 and value 1. This becomes key 2 and value 2. Alright, okay, so now since we have an empty dictionary in this particular example, so if you see the point number 1 which I have marked over here, let me give it a different color. Let's see if I can give it a different color. Okay, alright, I can do that. So the one you can see over here. Okay, let's be more cleaner. So the first step is this. What is the first step? We are creating an empty dictionary, which will be nothing but the open curly bracket and the close curly bracket with no item inside the dictionary. Let's see an example of this. And let me try to open idle and try to demonstrate this. All right. Let's see this example working. Okay. So I'll do the same kind of step here. So I do purse is equals to dict. Alright, now if I try to print purse, you see I get an empty dictionary, which is open bracket and close curly bracket. Alright, I want to, the second operation is I'm trying to add uh, a key or a label with name, or the label name is money, and its corresponding value would be 12. So you see how this happens. So I'm trying to add the label money with the value assigned to 12. Let's see how, or rather if it works. Okay, so I try to do the same step. I try to add money label or money key, giving it a value of 12. Okay, let me try to print the dictionary right now. Okay, here it is. So here you can see I have my empty dictionary is now filled with one item, and one item is one key value pair, the key being money, value being 12. Let's try to add another key, which is candy, and the value being 3. Alright, I'll print the, okay, here I have. So I've got two items now, two key value pairs. The first pair is money and 12, second one is candy and 3. Let's try to add the third one, and yes, it should also work, should be no problem, and yes, it worked. Okay, alright, now let's try to get a particular item value. Alright, so the purpose of dictionary is that if given a key or a label, we should be able to fetch the value corresponding to that label. Alright, now that I have a dictionary which is called purse, and my current dictionary purse has three items: money 12, tissues 75, and candy 3. Alright, I want to figure out, I don't know what is there in that. For example, I just know that I have some dictionary called purse, and I want to figure out if there are any tissues available in this purse. So let's see if we try to do this. If we say, do I have tissues out here? Oh yes, it says 75. That means I have 75 tissues in my bag. Alright. I try to figure out the other items. Let's say I say purse of candy. Do I have any candy? Oh yes. So this is the way. So you see, the first way is how do we add an item to the dictionary is this way. And if I want to get the value of any particular label, we do it this way, right? So you can assign this. So you can say that I want to figure out how many candies does my purse have, and I say it like this. So this gives me, in fact, we have seen this gives me the exact number of candies I have in my purse, and I am assigning this to a variable so that I can use it later, so that I can say that how many candies did I have? Yes, I had 3 candies in my purse. Alright, this is a way to access a particular meaning or a particular value of the given label or the given key. Alright, this is this clear? I hope this was pretty simple enough. Let's move further and see what we have next. Okay, so here is a little bit of comparison again. Dictionaries are like lists, except that they use keys instead of numbers to look up values. We have already discussed this. We use keys instead of numbers to look up the values. Alright, so here is the differentiation that we use the function, different functions over here. For creating an empty list, we use list function. For creating an empty dictionary, we use the dict function. And how did we add elements to the list? That was using append method. Whereas here we are just doing this sort of operation, that is we are uh, giving your key inside the square brackets and adding it like this. All right. And this is how your list looks like inside the square brackets, and your dictionary inside the curly brackets. And the accessing in fact is almost same, but a little bit different, saying um, giving the index inside the square brackets and giving the key inside the square brackets. All right, so let's move further and see a few more things. Okay, this is almost the same details we have seen. The difference being just the access part. It is using the index in the list, whereas using the key in the dictionary is being shown in the slide. Okay, dictionary literals. So whatever you have seen or you have been seeing in these examples, inside the curly brackets are the literals, dictionary literals we are talking about. Okay, so dictionary literals use curly braces and have a list of key value pairs. Okay, in fact, this also we have discussed that you can create an empty dictionary using empty curly braces. Alright, okay, okay. Now you need to figure out the most common name you find in the coming slides. Okay, what did you see? Let me just run through again. So these are the names appearing. You need to see what is the most occurring or most common name in the given list which is running through. Alright, when I ran through one by one, you would have probably figured out, okay, marker occurred say 7 times, say 1, 2, 3. You might have begin your counting in your mind. Similarly, you might have done this for other words too. This is how the dictionary also stores it. Or okay, this figure tells how did you count in your childhood, right? You might have made lines and cut down, okay, how much count I have done so far, or something like that. Okay, so this is one more common use of dictionary, which is like counting, counting how often we see something. Alright, for the given example, we needed to figure out how many times the given word has occurred, or what is the maximum occurring word in the given list or the given items. Okay, let's see. We will be seeing a program for doing this. So as of now, what we have is just a very simple example of how this task can be done using a dictionary. Like the task being counting how often we see something. Right? We created an empty dictionary first of all. All right, and then we're saying my current count of this word is just one because I'm beginning with here, right? This is the beginning. Similarly, for the next word, CSEV. So the first word is CSEV. The count being one right now, I have identified that as the one, the count as one. I have noticed that word coming only once. Similarly for CWEN, so I initialize, this basically is nothing but the initialization of the words and their counts. So and hence I create a dictionary, something like this, the word and its count, the word and its count, and so on. All right. And whenever we find the same word, occurring again, we can add 1 to it. That is, we can increment the count basically. So you don't have a unary increment or unary decrement in unary increment and decrement is not there, but you can do using an assignment something like this. So you can say, because this particular expression is nothing but we are saying the current count. By this we mean that in my dictionary CCC, get me the count of CWN. And since I have noticed that word coming again, I want to increment its count by 1. And hence when you print out the dictionary right now, you get CSEV count as only 1, whereas CWEN, its count has become 2. And this is the way you can perform this task, the task of counting. The task of counting a number of times a particular item has appeared. Okay, let's move further and let's see what does this say. Okay, dictionary tracebacks. So what are the problems when you try to access an item in the list with an index which is not in the range? For example, I got a list of 1, 2, 3, and I know the indexes are 1, 0, 1 and 2. What if I try to access L of 3? I get an error, isn't it? So let me just try to show this to you. Okay, and let me try to make a list, and the list is the same 1, 2, 3, and I try to access L of 3. I get an error, list index out of range. I don't have an index 3 in my list L. Similarly, if I try to create a dictionary, CCC is equals to det, I have an empty dictionary. Alright, I try to do CCC of CSEV, and since I have not added any item with the label, with the key named as CSEV into this dictionary, and hence I get an error saying that's a key error, right? There is no key with the name CSEV in my dictionary CCC. My dictionary CCC is still empty. Alright, so this is how you get an error when you try to access an item which is not there in the dictionary. Alright, okay, let's see what we have next. When we see a new name. Okay, now slowly we are progressing to how do we write the program to perform our task. What is our task? Our task is to get the count of the most occurring word, right, in our given collection or the set or the list, right? So what do we have here? Let's try to understand the example in the slide. Okay, we have um, a given list. What is the list? List is names. This particular list is list of all the names for which we are trying to figure out the count or the words, you can say. So this list has few words, for example, CSEV, CSEV, two times, CWEN, CWEN, two times, ZQIAN, single time, right? Our program will be performing this task. It will be figuring out how many times a word has occurred or which is the maximum occurring word. Let's see then. We try to create an empty dictionary out here first. Given a list, this is being given to us that this is the list of names you need to figure out or get the count for. Next, now we are trying to loop over in the collection given list so that we can figure out the count of each word in the list. For name in names, for name in the given list, for each name. So if the name is not in counts, and what is counts? Counts is right now an empty dictionary. So if name is not in the counts, yes, in fact, we do not have any item right now in the dictionary. So if we are, so what does this piece of code means is we are here first time. That means the word is identified only the first time now. Word is first time, and hence count is one. That is the we are identifying the word only the first time now. So we have given the count as one. Counts for the given name as one. Uh, let's say the word has come again. Okay, let's for example say we identified the word as CSEV and we gave it a count of 1, for example. Now we are identifying, we are seeing the word CSEV once again. It doesn't go to the if condition, it doesn't go here, it goes to the else, and what it does is rather than giving it 1, because we already have the count of CSEV as 1, the word is coming again. Now we need to increment it. So we are doing the same task, that we are incrementing the current count of given name by 1. Very simple, isn't it? All right. Um, okay, let's move further and see few of the methods. All right. We got few methods in dictionary objects also. We'll be discussing only about the important ones, and you can explore. There are many methods, and as I said before, if you need any help on what is available, you can always try to take help of the built-in functions dir and help. So this tells what all is available to you. So as you can see over here, the dictionary object has got lot many items in it, right? Lot many members and methods. All right, so we'll be discussing only few which are most used, and rest, if you find a need, you can explore. All right, let's see what do we have in this slide. So the slide says this pattern of checking to see if a key is already in a dictionary and assuming a default value if the key is not there, so common that there is a method called get that does this for us. So what if the key is already present? It gets, the value of that key gets updated. So you should be very cautious about it rather than directly going and updating it, because the existing key will be overwritten rather than, so for example, if I already have a dictionary with say hello and one and Python as two. Alright, now if I try to add d of Python is equals to 5, what happens is the key is not added into the dictionary again. It is not added, not added. Alright, no new key is added. Rather than what happens is the count is updated and the count of existing same key becomes 5. This is updation. Alright, so you should be cautious about it. Alright, and we have already seen that how do we get an item from the given dictionary? That is by giving the key for which we want a value. So you need to, so rather than just assignment, we can remove this, and this gives you the value for Python key. That is 5, isn't it? Alright, so there is another method to get a value of a particular key, which is called get. How do we use this? We use it like this. So we're trying to do what? We have the dictionary called counts. You can consider this dictionary as this below, okay, something like this, where you have the words and the count, which was there in fact in the previous slides. You can consider this as the dictionary, and we're trying to get value of the key name. Okay, what does this 0 signify over here? This gives the default value if the uh, key is not found. Let's try to explore this particular option. Okay, this is important. And okay, what do I do now? I create a dictionary with D O O. Okay, I give CSEV so that it is aligned to the given example. And next I give CWEN. Probably I'm giving the right names. Okay, S3. Alright, we're saying we need to get the value of a given key. So the second argument, which is 0 right now here, is default value which we want to give to that key if the key does not exist. So if you try to get the value for CSEV without giving the second argument, you get the corresponding value as 5. If you give, say for example, I'm just for the print sake, for example, d1 is d.get hello, and what happens now? Okay, there's no key, so we don't get any value, right? Okay, I try to get another one. Okay, so you don't get any value over here. What if we want to give a default value when you're trying to get the value for a given item, given key? So d1 is equals to d dot get Python, and give me the value 0 instead. So now if you try to print d1, you get 0. Alright, so this is default value if the key does not exist. Otherwise you would get none instead of a particular value. Okay, This is the first method, which gets a value of a particular given key. All right, let's see another example. So how can we put this into our previous program? We are trying to improve this program. This was our initial program, very simple one, easy to understand, but we're trying to improve on it so that we can better optimize it and get the same task done. And let's see how we have given how we have used the get method to do the same task. Now, since we know that if the key does not exist, so if the given key name, that is name, does not exist, we're going to get a default count as 0, and hence we have reduced our 2-3 steps of doing this if else condition, isn't it? We don't have to do this because by default the get method does it for us. So if we are encountering the name for the first time, this get gives the output as 0, and 0 plus 1 gives us 1. So count is updated correctly. What happens if we try to access the same name? So what happens if we are encountering the name once again? So the get method gives us the exact value of name rather than the default one. So the next time when we try to do this, we get this get method gives us 1, and 1 plus 1 becomes 2. And hence you get the correct output as the previous one. Alright, so this is how we just optimized our previous code to get a count of a word. Okay, so again, this is what we did to simplify our counting program. Okay, this is a kind of pieces built together to give you a better program. Like the text would be taken as an input from the user, right? So if you can see, we have used raw input over here. So the text would be given by the user, or the sentence for which we need to uh, provide or give the count for. Rest of the program as of now, if you can see, the counting part remains the same we discussed, isn't it? The part which varied is we tried to get the sentence from the user, and we try to split it. And if you remember from our previous session that what split does, it splits the given program given I'm sorry, so it splits the given sentence or the string based on spaces, or white spaces rather. Right, so if you split the given sentence using white spaces, you get words, and these words come in the form of a list, and hence this list is used in this program to do the same task. Alright, so I hope this is clear. So what extra thing is added in this program is that you are trying to get input from the user instead of hard coding the words as we did in our previous example. We're not giving a particular specific set of words every time. Rather, we want to make it a little dynamic so that user can input his own sentence and get the count of each word. All right, because that is the end goal of this program, that should be as dynamic as possible. Okay, here is a very good example. So we got this particular sentence from the user, which has, you can see, lot many words repeating lot many times, and we are trying to figure out our highest occurring word. which I believe here is D. Alright, marked in green probably? No? Yeah. So if you see, try to map this input. So this is the input we are talking about. This is the input given by the user using the raw input. Alright. And this is the output of the split performed, and this is the output of the counting part, isn't it? So if I talk about this, so if I talk about say, okay, let me try to do this. Okay, all right. So if I talk about the given input like this is the portion of program which, so this is number one, this is probably number two, this is number three. So I have separated my program into three parts, number one, two, and three. So this is probably number one, this is number two, this is number three. This is the output of number one, that is user sentence. Output of the number two piece of program in the previous program, if we can relate it. So number two piece of program does this, and that is it splits the given sentence into these words. And number three piece of program does the counting part, and you can see in the green the highest number of times which word has occurred is D. Alright, hence we see how we have integrated our small pieces of code into a good, decent program, isn't it? Alright, so okay, this is what probably I discussed. Number one, two, and three. Number one, not in fact, so a piece of it till here. Number two, and number three. Alright. Okay, so let's try to see how do we loop in dictionaries. So even though dictionaries are not stored in order, so as we discussed, dictionaries are unordered collections. So even though they are not stored in order, we can write a for loop that goes through all the entries in a given dictionary. Okay, so what the for loop does, what the below for loop, in fact, this is very specific to say that this for loop does is it loops over, it goes through all the keys in the dictionary and looks up all the values, isn't it? So what this does is, if you try to loop over in this way, so what is counts? Counts is the dictionary we're talking about. It has got three items and three key value pairs rather. We're trying to loop over in each key. Remember, when you try to loop with one iteration variable, just one iteration variable, we'll see how we can loop over using two iteration variables. So if you loop over using one iteration variable, that variable is going to loop over in keys by default, unless you do it in the values. We'll see how we can do that also. So by default, it's going to loop over in the keys. Okay, so for key in counts, print me the key, and counts of key gives you the value for that key. Value for key. All right. So hence we just, as you can see, it is not in the given order. It is not ordered. Since we are saying that, repeating again, that dictionaries are not ordered, and whatever you try to print also might come in a different order the next time when you try to print it. All right. So we're trying to print the keys and values in the given dictionary. It's very simple, just a simple for loop. which loops over in the keys right now, and we'll see in upcoming slides how do we loop over in using different scenarios like values or two iteration variables and so on. Okay, in this slide we are going to talk about um, a few other methods. So we are trying to talk about um, in fact four methods over here. The first method being list. It's a generic method, as we discussed in our previous slides, that generic method is something which can be applied into different data types. It is not specific or particular to only a single data types. And you can see here this method list converts the given collection into a list. So what it does, let's try to run this, and let me just show you. So I will create this, say for example, let me create my own, or I think I have already. So what is the, okay, good. I have this dictionary. I have this dictionary with two items, and what I'm trying to do is I'm trying to apply this generic method list onto this dictionary. All right. So what it does is it does not consider the values of the dictionaries, rather it just converts all the keys as list output. Alright, so values are not considered here. Let's move on to the next function, which is specific to dictionaries, and that is why we are accessing this using a dot notation. So we are saying that given this dictionary, I have this method, I want to see the output of this method using the dot. Alright, so let's see what is the output of this particular method. Okay, so in my given dictionary I have the dictionary D. Alright, I'm trying to do the same, D dot keys. Okay, what do I get? I get a list of all the keys in the dictionary, right? Similarly, the next method, as the name suggests, it gives out all the values of the dictionary as a list. So if we do d dot values, what we get is a list of all the values in the given dictionary. Alright, let's move on to the third method of the dictionary object, which is d dot items. What this one gives is very important to understand. So all these methods are pretty much used in loops, for loops, and to loop over in different scenarios. It's very important. All right, so what this last method in the slide tells is we are trying to get all the key value pairs of the dictionary. So this item returns us, so the output, if I say, is list of all key value pairs. All right, and these pairs are coming as a tuple output. If you can, if I mean, we have not discussed this, but whatever you see inside the small brackets separated by commas are tuples. All right, so what did we learn from this is we can get only the keys of the dictionary, only the values of the dictionaries, and we can also in fact get all the key value pairs in the given dictionary. So what is a tuple? So as I said, this is a tuple. It is coming soon. We'll discuss about this very soon. All right, let's move further. Okay, as we said that the previous slide gave us three different methods to use upon, and I also emphasized on that how this is very much used in for loops. I will see this in these slides. So we loop through the key value pairs in a dictionary using two iteration variables. As I said, we're going to discuss this. So this is what I was talking about, and you can separate the iteration variables using a comma, and that is the way it actually becomes a pair of two iteration variables. It a pair of iteration variables, right? So what we are trying to tell here is, you remember items gives us collection or a list of key value pairs. Now we are trying to loop through all the key value pairs together. So one pair at one time, one key and value at one time. So AAA becomes the key, BBB becomes the value, and hence you can see in our dictionary key and the value, key and the value, and so on. Right. So very handy, but it is very useful that at times you would want to loop over in keys and values together rather than just keys or just values. Also to remember is that each iteration, the first variable is always the key, and the second variable is the corresponding value for the key. Okay, let's move further and see. Okay, now here is another program which in fact uses our previous piece of the third piece. In fact, this was our third piece in our previous program, and we have written a new piece over here. All right, let's give it the name 4 and this one as 5. Okay, so what they do basically, so we are trying to run now. Instead of giving one sentence at a time, that is one sentence taking input from the user, but now we are trying to open a file. You see here, we're trying to open a file and try to read all the data of the file at one shot, right? And we're trying to see all the words in fact in the given file. We're dealing with files rather than user input, raw input, right? That is the difference right now here. We'll see further what else we are trying to do here. The first is in the fourth step, in fact, what we're trying to do is open a file and read the contents. As simple as that. All right. In the second one, we're trying to count the number of words. So what we are basically doing in the third step is creating a dictionary. Right? This is creating dictionary of words and count. All right. This seems pretty much new. The fifth step seems new. Let us see what we are trying to do here. We have two variables initialized to none, big count and big word. So we're trying to see what is the highest occurring word here. Okay. So till now we just try to see manually that what is the count of, like here in the output we saw that okay, hey, this is the word, but this was seen by our eyes, not by our program, right? We're trying to embed the same thing over here and see. Okay, what it does for word and count in counts.items. So we are trying to loop over in all the key value pairs and if try to see what is the biggest or the highest count word, and we are assigning the highest count word and its count to these two variables. All right. So the condition being, if it is none, so the first time the first word and count would be assigned, that is the initialization part. The second time, that is why we have used or here, not and. The second time, if we see any count going greater than our current big count, becomes the big count. All right. Okay, this was the end of this current discussion of the program, and we try to start from very small program, that is very small piece. We try to build these pieces together to form a program, just to create a dictionary of all the words and their counts. And at last, now we have seen how to put together all pieces, okay, and get the file as input, read the contents of the file, create a list of all the words uh, in, in the file, and then count, that is create the dictionary out of this list, dictionary of words and their counts, and then at the end figure out which one is the highest occurring word in the file. Okay, here we come to the end of our discussion also about dictionaries and the summary. Let's try to see the summary. What is a collection? We saw about the collection, list versus dictionaries, dictionary literals or constants, which are done inside the, which are mentioned inside the curly brackets, curly braces, right? And then most common word was our program we talked about throughout these slides, and the get method. We also discussed about the keys method, the values method, and the items method. All right. We also talked about it basically is a sort of hashing we call in other languages, but it is unordered. All right. And we also saw how do we loop over in dictionaries, using one iteration variable, using two iteration variable. And okay, tuples we have not discussed, but we have seen that it is something inside the small brackets, which we have not discussed. We'll be discussing it in the next step. Okay, sorting dictionaries is something we have not talked about. Let me see if I have the content to that. Okay. Okay, so we need to discuss about a little bit about sorting, how sorting works on dictionaries. Let me try to demonstrate here. Let me try to add in the current dictionary. So I have a dictionary D, which is right now CSEVCWEN. All right, let me try to add a few more items to it. So D of hello, and let me add 5, and D of Python. Lately, these are the words which I like most, hello and Python. Okay, all right. Now I try to print D, which is the collection of 4 items right now. So let's see if we can use the sorted method on this dictionary. All right. So as you can see, this is how it works, isn't it? So you can sort a dictionary using the sorted method, which we have also discussed in our previous session of list sorting. All right. So going forward, I will have one or two slides which will talk specifically about sorting uh, in the dictionaries. But for now, you can consider this as working, right? You can use the sorted method on dictionary. All right. In fact, there should be something called sort also. If I say help on d dot sort, no. Okay, I don't have a method called sort. So let me see dir of d. Okay, so these are the methods available, and yes, I do not have a sort method which does in place sorting like we did in lists, but we have this method called sorted, and which applies to list, dictionaries, tuples, and so on. So we can use this method to do our sorting stuff. All right. I'll be sharing out some quizzes and questions very soon to the LMS so that you guys can try solving them. Okay, so any questions so far? All right, so let us see if we have more to discuss, and okay, we have things to discuss. So let us just see if we can discuss more. Tuples is another thing. So let us try to cover some things in tuple. Maybe, yeah. All right. So let's begin with the next data type, and we'll be discussing a little bit about tuples. And in our next session, we would continue this discussion further. So we are discussing today about the next data type, which is tuples. Let's see what tuples are. So tuples are another kind of sequence that functions much like a list. Okay, so they are like lists, same as lists, but being some differences. They have elements which are indexed starting at 0. So it is almost the same as that. If you consider a list, what a list looked like is this. Very simple example. All right, a collection of the three numbers. If I have to talk about a tuple out here, the same tuple will become 1, 2, 3. Different in the notations, isn't it? But again, both are collection of items, and they are uh, ordered one again here. The difference being, the main difference being that tuple is immutable. Tuple is immutable, whereas list is mutable. That is, we can change items in the list, we can change the list, we can update the list, we can remove the elements from the list, but we cannot do so in tuple. Okay, so something like we'll see how we cannot do. So what is x over here? X is our tuple of uh, three strings or three names. So as you can see, there is no much difference in forming the collection, just the notation of the boundaries, like the representation rather. So representation, instead of square brackets, we have used the small brackets. All right, so the indexing works here too. So if you try to get the second element, this is how you get it, x of 2, you get Joseph. All right, here is another tuple. When you try to print it, you get something like this. And if you can see, probably this is not very clear, but if you see max, right, max is the function. We have tried to use max of y, and max is a built-in function. So what does the max function output? So my tuple is t is equals to 1, 9 and 2. I'm trying to figure out max of t. So I get maximum number in the given tuple, right? And if I try to access the second element, it's the same way as you access the second item in the list. All right, and the looping also works the same way. If I want to loop over in this tuple, so I say for I in t print I, and that's it. And you can see I just looped over in all the items in this tuple one by one and printed them, right? Okay, but so it is, as we saw in our previous slide, it is almost the same as list, just the representation wise, and the most important difference being that tuples are immutable. We cannot change them. And this is how you get an error. For example, if I talk about a list, right? So if I talk about a list, say this is my list, and this operation is very well allowed. That is, we are trying to change the element at index number 2. Like 7 will be changed to 2, and this is the output. Now y is ABC. This is what? This is a string. Alright. Now we're trying to update the character at number 2 to D, but this again is not allowed because list is mutable, string is immutable, tuple is also immutable. Okay. All right. So, and similarly, Z is the tuple of three values. I'm trying to update the value at number 2 to 0, but again, this is not allowed. All right. This is the major difference between lists and tuple. Things not to do with tuples. You cannot do in-place sorting with tuple. The sort method is not available. The append is not available. The reverse is not available like lists. So the list object had all these three methods available, but tuple cannot do this because of the reason being it is immutable. All right, we cannot change the tuple. All right, so there are very few operations available with tuple, though here it has showed two. This is a pretty old slide, but if you try to figure out here, so t is my tuple, and if I try to do dir of t, okay, in fact, I think this says correct. We have in fact only two methods, count and index, in the tuple object. All right. So the number of operations also are less due to tuple being immutable. Okay, so tuples are more efficient. Okay, so why they are efficient? The main reason being, since Python does not have to build tuple structures to be modifiable, since Python does not have to do much of effort on adding, shifting items and rearranging them, they are simpler and efficient. So in terms of performance and memory use than list, because lists, if you change any item in the list, it has to rearrange to maintain the integrity of the list. But in tuple, you don't have to worry about the deletion, updation, because those operations are not allowed with tuple. All right. Okay, and let's see about tuples and assignment. This is another important use case of preferring tuples than lists. We can also put a tuple on the left hand side of an assignment statement. So this in fact is called something parallel assignment. This is called uh, parallel assignment. Assigning multiple values together to multiple variables. So x gets 4, y gets Fred, and yeah, we try to print y has already got Fred. So this is called parallel assignment. Multiple assignments using a single assignment operator. All right, so this is very much clear, pretty much clear. So the first usage being it is very efficient in terms of memory and processing. Secondly, it is very good for parallel assignments. All right, and okay, the next one says items method in the dictionary. So we have already seen that when we try to loop using two iteration variables, these two iteration variables was nothing but a tuple. And also the return value, what we try to, not in fact return, what items method returns is also a tuple, isn't it? So this is again one more use of tuple, how we performed simultaneous access of each key value pair in the dictionary. All right. Okay, so this is one more aspect where you can see the comparison operators. So you can directly compare two tuples using the comparison operators. So how you can do the comparison operators work with tuples and other sequences. If the first item is equal, Python goes on to the next element and so on until it finds elements that differ. So for example, what does this sentence says? So when you're comparing two tuples together, this is number one, this is number two. When you're comparing these two tuples together using the assignment, not assignment, using the comparison operator. So what happens is 0 is compared to 5, and since 0 is less than 5, so this becomes true. If you remember, the comparison operators always returns us Boolean that is true or false. All right. So in the second example, 0 is not less than 0, but it is equal in fact. What happens if it finds equal? So if Python finds the elements as equal, it goes to the next one. So it skips this. So it does not give output based on this comparison, since these are equal and we're trying to compare the inequality, that is less than. So 1 is less than 3. Yes, it is less than 3. Hence, we get the output as 0. Okay, and so on. If you try to see, this is how the comparison is done, step by step, element by element. Okay, let's see another example where we are trying to sort list of tuples, and this in fact is related also to the sorting of dictionary. We can take advantage of the ability to sort a list of tuples to get a sorted version of a dictionary. As we discussed in our previous slides uh, of dictionary, that you can sort a dictionary using the sorted method, but by default the sorted method sorts the dictionary based on keys. Alright, now we're seeing how tuples can be used to sort the dictionary. So first we sort the dictionary by the key using the items method. Let's see what we are trying to do here. We have a dictionary called D with these items, and we're trying to get the items, that is key value pairs. So what this output is, it is a list of tuples, isn't it? And when we try to do sorting on this, it's pretty simple because this sort is a list method. And remember, it is very much different from the sorted method. Okay, so since this is a list, we are able to sort this list. Okay, this is an example of sorted using the sorted method. We can also use if you see the sorted method, we have passed this list of tuples to the sorted method, and like we got the output in our previous slide using the sort method is the same here. All right, and yeah, so this is a loop running on sorted items of the dictionary. Right, this is how we can say that we have sorted the dictionary based on the keys. All right, okay, so let's see if we can discuss. So yeah, so let us discuss further. And sorry, so I made a mistake. All right, so let us see further. And so we were discussing about sorting, and we saw that we can sort the dictionary based on keys. Let's see how we can use sorting to work based on values instead of keys. So there's a trick to it that we can do. So this is the trick, in fact. So you see, what is the trick is that if we could construct a list of tuples of, so till now we have been sorting list of tuples, isn't it? This was nothing but list of tuples. This was list of tuples. and we are saying the same thing, that if we are able to successfully build list of tuples of the form value and key, not key and value. Till now we had the list of tuples of key and value, right? Now what we are saying is, if we are able to do uh, create a list of tuples of form value and key, we can sort by value also, right? Because it takes the first item for sorting. Sorted method takes the first item to do the sorting. All right. Okay, so how did we accomplish this? Let's see. C is the dictionary with 3 items. All right. We try to create an empty list. This is an empty list. Okay. We're trying to loop now in this list of items, that is key and value. But in the list, output list, so this temp becomes our output list or intermediate list, basically, where we are trying to perform the trick. So in this empty list, we're trying to append in the form v comma k. We are looping in the form k comma v, that is key and value, but we are appending the items in the form v comma k. All right, so this way now if we perform the sorting on this particular list of tuples, and remember now our tuple is uh, arranged in the form v comma k, value and key. So if we perform the sorting now, the sorting happens uh, based on values. This was a little trick that you can apply to perform sorting based on values instead of keys. Okay, this was okay. This is a program to list out 10 topmost common words. So what we're trying to do, let's quickly discuss this. We're trying to open this file, create a dictionary, loop over in the file. Okay, each line we are splitting and finding the words, and creating a dictionary, isn't it? So counts is a dictionary of words and their count. Now we are creating the list, an empty list, and in the given dictionary we have formed, we are trying to create another list, that is lst, which will append the count and words the opposite way, right? Count and words, that is v comma k. We are following the previous slide, that is using v comma k. So this is not good. V comma k. Okay, count and words. And now we are applying sorting. Reverse is equals to true. What happens in this is this, that you sorted based on values, but now we are trying to find the topmost, right? The most values, by default it sorts based on that is in ascending order. By default the sorting happens in ascending. If you give this reverse argument as true, it does in descending. All right, so here we are trying to do the same thing. We are sorting by value, but in the reverse order, that is the highest being at the first place. So hence we get the top 10 common words with the highest counts, top 10 highest counts words. Wasn't it simple? So see how we have accomplished this using lists, dictionaries, and tuples, isn't it? All right, so let's see a very short version of this. Okay, this is a very good example where we talk about list comprehension. Right, this is a bit advanced topic, but what I would do is I would discuss this now, and I leave up to you guys, so you can come up with your questions, and I'll try to cover more on the comprehensions. But I'll discuss a little bit about this right now. So we are trying to optimize this piece of code in a very short form. Let's see how we have done this. Our goal was to find the most 10 top 10 common words, right? And list comprehensions are something to create a dynamic list, right? So it is basically, in short, I can say it is creating a list from a list. It is creating a list from a list. All right, and you have been given a list from which you are creating another list. So what is the given list is c dot items. From c dot I, what c dot items returns the list of key value pairs. Okay, so for each key value pairs in this given list, remember creating a list from a list. So I have got a list here, c dot items. I'm trying to loop over using key value, that is two iteration variables in this list, and I'm returning. Remember, this is the return part of the list. This is the beauty of comprehensions. In one statement, you have performed so heavy operations. So looping over in each key value pair in the given list, I'm trying to return a value key. So what the output would be, this particular list is going to remember. Notice the square brackets over here. So this particular expression, complete expression, is this expression is inside square brackets, which tells that we are using comprehension. So the end result would be that each of these output would be appended to the output list. So v comma k, each v comma k will be appended to the output list, which in turn would be given to sorted, and hence we get output like this. So you see in the single statement how we have performed a very heavy operation. This is the beauty of list comprehension. Okay, um, this marks the end of our discussion for tuples. There is not much to talk about tuples, but the remaining thing, that is, if you come up with your doubts or if you need any clarifications, we can always do that based on your inputs. So I'll be waiting for your inputs. If you have any inputs, I will incorporate them and try to. All right, so let me see if my audio settings are correct, and all right, so So here we are at the end of today's session. Let's see the quick summary of it. We have discussed about tuple, immutability, comparability, sorting in tuples, how we can use tuples to sort dictionaries based on values, and yeah. So if you guys have any uh, doubts or questions, you can ask them, and I'll try to address them on our next session. Thank you very much.